The first thing I want to do is define what a solution reaction is and what it isn't. If we take those two beakers back there that we had, A and B, remember those beakers? And we pour them together, something might happen. How do we judge whether a reaction has happened? Well, the rule is that if you combine solutions of two ionic compounds, and you could write this two electrolytes if you wanted to, because that really applies too. If they're mixed up, a reaction is said to occur only if ions leave the solution somehow. How could ions leave the solution? It might be a precipitate form, right? Or one of the ions might be H plus and one might be OH minus, and what would happen then? They would combine to make water. Those ions would be pretty much gone, and the water molecule would be formed. Or maybe they would form a gas, and the gas would bubble out of the solution. If there's any geology majors in here, you use that test to test for carbonate ions, right? Geoscience majors out in the field, got a piece of rock. The boss says, is it carbonate? You pull out your dilute HCl, put it on there. If it bubbles, it passed the first test. Okay? Ions are removed from solution because that's carbon dioxide bubbling off. And that's because carbonate ion has been consumed and has left solution. So we have a reaction only if ions leave solution. Suppose the two solutions we had was calcium chloride, one of them, and potassium nitrate, the other one. And if we mix the aqueous solution, no gas forms, no solid forms. In fact, nothing happens. The calcium chloride dissolves in water to make calcium ions, 2 plus, aqueous, plus 2 chloride. The potassium nitrate, likewise, forms K plus, aqueous, and NO3 minus, aqueous. But the ions don't interact with one another. All the ions stay right there. Now, if the ions were going to interact with one another and produce solids, we would have to know the rules of solubility before we would be able to predict that. Well, that'll happen early next week. We'll learn the rules of solubility. But for the time being, we would notice that calcium ion could form a compound with chloride ion, which is where it came from, and it could also form a compound with nitrate ion. So we could have calcium nitrate forming, or we could have calcium chloride reforming, but both of those are soluble. So no ions would leave on that account. K plus could form a compound again where it came from, potassium nitrate, or it could form potassium chloride. That's soluble too. So there are 4 possible combinations. Now, you can't make a plus-plus combination. It has to be a plus-minus. So we have 4 combinations, and they're all water-soluble. Okay? They are all water-soluble, and therefore no reaction occurs. Okay, got that clear in your mind? No reaction occurs. Suppose we took that solution and we put it right there and we waited until Monday and came back, assuming nobody stole it or dumped it or did anything to it, and all the water evaporated, what would be left? You think it would go back to calcium chloride and potassium nitrate? Would there be any potassium chloride and potassium nitrate and calcium chloride? I think there would be. But I also think, depending on the solubility, there would be potassium chloride and calcium nitrate. All 4 of those compounds would form crystals. And the relative amounts of them would depend on the solubility of those particular salts. So, the major types of ionic reactions we're going to be studying starting Monday are precipitation reactions where we form one compound or 2 compounds that are insoluble, neutralization reactions, which are acid-base, and reactions that form a gaseous product. We won't say much about those.